Today we're going to be solving equations involving absolute value. Okay, so first remember that absolute values are always going to be positive because what absolute value is the distance from 0. So if I plug into for x, so I have 23 minus 3 minus 4 times 2. So order of operations, absolute value is like a grouping symbol, so it's like a parenthesis. So I do everything inside my parenthesis first. 3 minus 8 is -5. The absolute value of -5 is 5, because remember, absolute value means distance from 0. So 23 minus 5 is 18. Okay, so like I've been saying, absolute value is the distance a number is from 0. So let's look at this. The absolute value of x equals 4. So from 0, I go 4 over. So one of my answers is 4. But we have another one in the negative direction, the absolute value, that's -4. Okay, so solving absolute value equations. There are two cases to consider. We consider inside the absolute value is positive or negative, and then positive or 0, and then inside is positive or negative. So meaning what I do is I set what's inside my absolute value sign equal to a positive and a negative number outside of our absolute value sign. Okay, so let's get into an example. First, you have to make sure that your absolute value sign is isolated. In this case, it is. So I have two equations that I'm going to set up, because 6, the absolute value, I shouldn't have the absolute value symbol in there. 6a can either equal positive 54 or 6a can equal -54. You have to set up two equations. I divide by 6. 54 divided by 6 is 9. Again, I divide by 6. -54 divided by 6 is -9. So, graphing my solution, -9 and a +9. Okay, next example, graphing the solution. So, again, you set up two equations. My absolute value sign is isolated. So, I have -4 plus x equals a +2, and -4 plus x equals a -2. Now we solve this equation. So, I add 4 to both sides. That results in x equals 6. I add 4 to both sides. That results in a +2. So my answer is 6 and 2. Okay, solving this equation, just more complicated examples. We're going to keep increasing how complicated our examples are. So, set up two equations. 9x minus 4 equals 32. Or 9x minus 4 can equal a -32. I add 4 to both sides. So, 9x equals 36. I divide by 9. X can equal 4. I add 4 to both sides. 9x equals -28. I divide by 9. X equals -28 over 9. And that's okay to have fractions. A lot of time you're going to have fractions. Remember, I like my answers as improper fractions. So make sure you leave them like that. And make sure your fraction is reduced. There's nothing that goes into both 28 and 9. Okay, so we have to isolate the absolute value signs. Okay, so that means I need to first add 3. So before I do anything, I have to add 3 to both sides, and I get 11. Now that my absolute value is standing alone equals a number, now I do 7 plus 2r equals 11, and 7 plus 2r equals negative 11. And then I solve from here. I subtract 7 from both sides. 2r equals 4. I divide by 2. I subtract 7 from both sides. Negative 11 minus 7 is a negative 18. I divide by 2. So those are our two answers. Okay, so again, we want to isolate. Instead of putting the bars there, I'm going to put the absolute value. Okay, so that has to be standing alone. Okay, now this one's always a complicated one. And I add this one in here. This is a common problem that I do in my Algebra 2 with trig class. So what you need to understand is you cannot simplify the 1 minus the 5. The 5 is being multiplied to the n plus 8, that absolute value. So I first have to subtract the 1. Then I divide by a negative 5. Okay, so again, you have to understand that I had to isolate the absolute value sign. Okay, the 5 is being multiplied to that absolute value sign. So I can't subtract the 1 from the 5. The 1 is kind of standing on its own. So now I set up my two equations. Now that my absolute value sign has been isolated, I subtract 8 from both sides to get 3. I subtract 8 from both sides to get a negative 19. Okay, so looking at this, the absolute value equals negative 37. So the absolute value of something equals a negative 37. I want you to think about that. Think about this. Absolute value are always positive. Okay, I have the absolute value equals some negative number here. So don't just jump into the problem first. Think, does the problem make sense? This problem doesn't make sense because you have the absolute value equaling a negative number. Absolute value can never equal a negative number. So this answer is no solution. Okay, write an equation involving an absolute value for the graph. Okay, so what you have to think about here is you're always going to have an x minus, I'm going to say the midpoint. You could also look at it as the center equals my distance from the center to the endpoints. So I need to find the midpoint. I need to find the average of negative 5 and 1. So I need to find the center. So what's the length basically of this segment? 1, 2, 3, 4, 5, 6. So that segment is 6. So you have to go in 3 units, in 3 units to get my center point. So now I have my center. My center is a -2. Distance from the center, okay? This distance from the center to either endpoint is 3 units. Rewriting that to make it look a little bit easier or a little bit more nice in terms of some mathematics is the absolute value of x plus 2 equals 3. Another way we can find the center is take -5 plus 1 divided by 2. So -5 plus 1 is a -4 divided by 2. That gets me a -2. And then just figure out the distance from -2 to 1. Well, that's 3 units. Okay? Okay, so that is my video on solving absolute value equations.